A capacitor is an electric device which consists of two conductors separated by a dielectric medium. Here you can see that two parallel plates. The plate A, its surface is meter square in meter square, and another conductive plate B. There is a medium in between plate A and B. So its dielectric permittivity is epsilon, and distance between the two plates is d. The one side of the plate is plus q. The uniformly charge is distributed over this surface, and the other plate is the minus q. So one is positively charged, the other plate is negatively charged. Here we can see that the other view of a capacitor. This is the typical symbol of a capacitor. Here, so when I connect a cell, a battery across a capacitor, the charge started to distribute over the surface. So when a plus side of the cell is connected to the one side of the capacitor, so here it becomes positively charged. The charge gets uniformly distributed. And at the other side of the capacitor, it is minus charge, which is uniformly distributed over the surface of the one side of the plate. So this is Q plus and the other plate is Q minus. We can see that there is a dielectric medium between the plates. The dielectric medium of many types. So air is an example of dielectric medium. It may be mica, a paper, or oil impregnated paper, and ceramic. So there are different type of dielectric materials we can select. So as the capacitance is directly proportional to the dielectric medium, so by changing the medium in between the plates, the capacitance also will get affected. Its value changes with the dielectric and the area of the parallel plates and distance between the parallel plates. So today we are going to obtain that relationship of the capacitance and the area and the distance separating the parallel plate and the dielectric medium. So we can define the capacitance as it's the ratio of the magnitude of charge on either of the conductor to the potential difference between the conductor. So it is a ratio of the magnitude of charge, that is Q, on either of the conductor to the potential difference between the conductors. So potential difference is V. So capacitance we can write down as C equal to Q by V. Assume that there is a uniform charge density D over the plates and dielectric medium, then D can be written down as Q by area. So coulomb per meter square. So uniform charge density. So earlier we obtained the relationship of D and E. D can write down as epsilon E. So just bring Q by A here. So Q by A become epsilon times E. So if you rearrange, the Q become A epsilon E. The relationship of voltage and electric field is, so earlier we studied that the electric potential equal to electric field and D, electric field times D. So electric field become V by D. So now substitute the E here. Let's take it as expression number 1. This is number 2. Let us put number 2 in number 1. Q become A epsilon V by D. Now rearrange. Let us bring the Q on the other side of the equal symbol. So Q by V become A epsilon by D. So epsilon we can write now as epsilon naught epsilon R. So this become epsilon naught epsilon R A by D. See the charge to voltage. So it is defined as, what is the capacitance? Is defined as the ratio of magnitude of charge on either of the conductor to the potential difference between conductors. So C equal to Q by V. So this we can write down as C. So the final expression of C is epsilon naught epsilon R A by D. This is the capacitance of the parallel plate. The unit of this capacitance is farad.